So now I can actually find the time the ball hits the ground. And in doing so, that's going to give me my x-intercept. Because when the ball hits the ground, we know our height is going to be 0. So it's just asking at what time is the height 0. You're going to have an x-intercept on this side and on this side. Time is clearly not being measured negative, so it's going to be the positive 0 or the positive x-intercept. So let's factor this equation. I'm going to move it up a little bit more. I'll rewrite the equation. I just don't want us to get confused by looking at all the other work. So our equation is h of t equals negative 16t squared plus 40t plus 144. Okay, when I am factoring, the first step is to take out a greatest common factor. If there is a GCF and you don't take it out, you will not get the correct answer. So we're looking at this and we're going to take out our GCF. Negative 16t squared, 40t, and 144 can all be divisible by 8. Negative 16t squared divided by 8 is negative 2t squared. 40t divided by 8 is 5t. And 144 divided by 8 is 18. Now I can proceed to do my box method in order to factor this equation. My box method has me draw a box. Beneath my box, I draw 2 lines. I need to divide, oh, I didn't make it even. There. Now I'm going to plug in my first value, this is after the GCF is taken out, and my last value into the upper left-hand corner, so negative 2t squared, and the bottom right-hand corner, 18. I need to multiply this first term and the last term by each other. When I multiply negative 2t squared by 18, I get negative 36t squared. And I know what I'm looking for is a number that multiplies to be negative 36t squared and adds to be positive 5t. So knowing that, I know that I'm going to have 2 numbers. One is negative and one is positive because they have to multiply to be a negative number. The negative number is going to be the smaller number because they have to add to be positive. I'm going to start laying out factors. Like usual, I always start out with my 1 divided by the term. So we had our negative 1t and our 36t. That does not add to be 5t. I'm going to try 18t and negative 2t. That does not add to be 5t. I'm going to try 9t and negative 4t. And I'm going to notice that if I add these 2 together, it gives me 5t. So I found my 2 factors. I need to put them in the remaining squares. Once I have done that, I need to factor across and factor down. Negative 2t squared and 9t only have 1t in common. Negative 4t and 18 have 2 in common. And because these were both not negative, we're just going to go with the positives. These are both negative. We have negative 2t squared and negative 4t. So I'm going to get negative 2t as the GCF. And then looking across here, there is 9. That's the factor that's in common with 9t and 18. I'm going to write this out in factored form. So we have t plus 2 and negative t plus 9. I'm going to quickly just do multiplication and distribute to ensure that I factored correctly and my signs are good. So t times negative 2t gives me negative 2t squared. T times 9 is 9t. 2 times negative 2t is negative 4t. And 2 times 9 is 18. I combine like terms. And I'm back to that factored, or sorry, once we've factored out the GCF. So we're back to this original equation. So we know that there's an 8 on the outside of parentheses, but for factoring, in this case, it's not important because we're just going to set each part of our parentheses equal to 0. So t plus 2 needs to be set equal to 0, and negative 2t plus 9 needs to be set to 0. Because remember, the factored form is the way we figure out our x-intercepts in a quadratic equation. So for this portion, t equals negative 2. We talked about how we don't want an x-intercept that is negative. I can still put a dot there because that is where it crosses the x. But that's a negative 0, and in this circumstance, a negative 0 doesn't fit the context. I'm going to put my line down here. I'm going to subtract 9 from both sides. 0 minus 9 is negative 9. 9 minus 9 is 0. I'm going to bring down my negative 2t. I'm going to divide both sides by negative 2, and I'm going to get t equals 4.5. So my other x-intercept is at 4.5. So now I have enough information to continue my graph. Again, this is obviously not, oops, let me scroll down. This is not going to be perfect, but I know my x-intercept, so I could extend my graph. So let's go back up to the top. We know the time the ball hits the ground. So when h of t, when height is 0, the time is 4.5. So at 4.5 seconds, the ball hits the ground. Lastly, we're just going to talk about some parts to this general equation and what the graph means. Let me use a little bit darker color for the graph. I'm going to use bright orange. So we just can see it a little bit better. We've got the vertex, which is also our line of symmetry. We had the y-intercept. And then we had our x-intercept down here, which is, remember, we find it by solving for x when y equals 0. So we know that the domain of this in context, so domain is my x values. The only relevant x values in this equation is 0, because we're going to have our time is not going to be negative, all the way to 4.5. But after 4.5, it hits the ground and nothing is changing. So the domain in context of this problem is inclusive 0 to 4.5. The range can go all the way up to 169 as the max, and all the way down to 0. So my range, 169 is the max, 0 is the min. And so now I have my range. It's increasing. Remember, increasing and decreasing, you're looking at slope. So it's increasing from 0 to 1.25. And then it's decreasing from 1.25 down to 4.5. So when we're looking at increasing and decreasing, you're specifically going to write it in context of the x value. So we know we're decreasing from 1.25 to 4.5. And we are increasing from 0 to 1.5. Sorry, 1.25. Positive and negative. Sorry, I'm going to write this little slope is what we're looking at. Positive and negative, you're looking at what your y value is. So when my y value is positive, then it's a positive part of the function. In the context of this problem, our height is always positive and our time is always positive. So this entire function is positive because we are positive from x equals 0 to x equals 4.5, and that is the entire equation. So we know from 0 to 4.5. And that's it.